Good day to each and everyone. I am Jomar F. Calderon from Western Mindanao State University College of Engineering, presenting my research titled Silica Gel-Assisted Peltier Module as Primary Component of Portable Atmospheric Water Generator, or AWG, as an alternative water supply. Access to clean and safe drinking water is a fundamental human right, yet a considerable portion of the global population which faces water scarcity and contamination challenges. In response to this critical issue, innovative technologies such as AWG have emerged as potential solutions. This research delves into the performance and efficiency of an AWG system designed to extract potable water from the surrounding air. By exploring its functionality in various settings and weather conditions, this aims to assess its effectiveness as a sustainable water source, contributing to the alleviation of water scarcity issues. This study evaluates key environmental factors such as temperature and humidity and their impact on water generation, providing valuable insights into the feasibility and practicality of the technology as a reliable source of clean water in diverse contexts. The convergence of global warming, climate change, and the overexploitation of our water sources has resulted to crisis, the scarcity and shortage of our water supply. These environmental factors, coupled with human activities, are rapidly depleting the available water resources, affecting communities at a domestic level. As a consequence, households are grappling with the profound challenges of meeting their daily water needs. Fundamental tasks such as washing, cooking, and maintaining personal hygiene have become increasingly burdensome due to the erratic and insufficient water supply. This situation emphasizes the urgent need to explore alternative sources of water that can provide sustainable solutions to alleviate the distressing effects of water scarcity on households. Only one AWG apparatus had been fabricated and was positioned at the website Kabasalan Zamboanga to simulate rural setting duration of 2 weeks, and in Barangay San Jose Kawakawa, Zamboanga City to simulate urban setting for another 2 weeks. The apparatus has a plastic body frame with a dimension of 30 by 16 by 21.5 centimeter, installed with dripping tray, water tank, solar panel, electrical wire, solar battery, desiccant, Peltier module, heat sinks, and fan. Inside the apparatus, ambient air enters through the screen, and the air moist absorption will be accelerated by silica gel. Then the fan will regulate the airflow inside the apparatus. The Peltier module will be responsible for heat exchange to condense air moist dew. Then, the condensed dew will drip into the dripping tray and will be accumulated inside the water storage. And lastly, the dry air will exit the apparatus. For the design computation of fan airflow, air inlet and outlet, the fan that was used in the AWG is a DC brushless fan with an average efficiency of 50%, 9 cm in diameter, operates at 12 volt, and consumes 0.18 ampere and 2.16 watts. Airflow has 3.67 cubic foot minute or 103.98 cubic centimeter per minute. The area has 63.617 centimeters squared. This will be the minimum cross-sectional area required for the air inlet. The outlet has a 9 centimeter. Hole diameters has 0.8 centimeter, and the total number of holes is 1050, which has a computed total area of 74.219 centimeters squared. For the computation of dew point adapted from Magnus-Seconds formula. Ts is the dew point, T is the temperature, RH is the relative humidity of the air. A and B here are the Magnus coefficients as recommended by Alduchov and Eskridge. The values are 17.625 and 243.4 degrees Celsius respectively. For the average water generated, average volume equals to summation of volume over number of tests. For the production ratio, PR is equals to volume generated over daily water consumption demand. The daily water consumption demand here will be 3000 ml or 3 liters. As for the moisture absorption of silica gel, we computed by moisture extracted equals moisture absorption capacity multiplied by weight of silica gel. The image on the left is the internal setup, and the image on the right shows the section of the apparatus. This image is the isometric view we mentioned. For the experimentation and data interpretation, the water extraction process were done on a daily basis. Tools were allotted in each study area. The results were collected and measured using a 50 ml graduated cylinder, and temperature and relative humidity was measured at the beginning and at the end of sampling with digital LCD hygrometer. The daily samples which were collected for a span of 4 weeks was interpreted using a production ratio. Compare the volume of extracted water among varying environmental settings and conditions. During the volume determination, 700 grams of silica gel was used each week and replaced weekly to avoid saturation of the gels. A total of 5,617.5 ml or 1.4839 gallons of water was generated in the span of 4 weeks. The highest volume of water was generated in week 1 at Barangay Riverside, Cabasalan, Zamboanga, Sibugay with 1,493.2 ml. And the lowest was in week 4 with 1,188 ml at Barangay San Jose, Caloocan, Zamboanga City. The average daytime temperature recorded was 32.9 Celsius. As for the nighttime, it was 29.7 Celsius. The average daytime humidity was 60.2%, and as for the nighttime, was 75.07%. The table here represents the weekly volume determination with corresponding environmental setting and condition. As for the total volume generated during week 1 was 1,400 ml. For week 2, 1,485.7 ml. Week 3, 1,188.3 ml. And for week 4, 1,450.3 ml. With the results accumulated within 4 weeks, all water volume to daily demand ratio or the production ratio are less than 1, meaning the daily generated volume is less than the daily water per person. In conclusion to this, for the water generation, the results of this study demonstrate that the performance of the apparatus is affected by environmental conditions, particularly setting, temperature, and humidity. The silica gel-assisted filter module was effective in generating. For the production ratio, the target water volume generated per day failed to meet the daily water consumption of a person, which is 3 liters or 2,000 a day compared to the daily average generation of 206.9 ml. Nevertheless, considering the primary objective of the study, water extraction was successful.